participants will gain immensely from this event. Without further ado, I now call upon Mr. Sen to start with the event.
Thank you, Aditi. Thank you for making that amazing introduction. Also, thanks to all the organizers who have made this possible, and especially thank you to people who are here in the event. So this is the best way for me to spend my Friday evening, and I hope that I can make it worth your while. Firstly, today we have an agenda. At the end of this session, be able to find out the basics of system design. I mean, be able to define a system as computer engineers. Okay, the way we are going to do this is by taking a particular example. We are going to be taking an example of connecting to a website, like let's say Facebook. So at the end of this meeting, you should be able to clearly say when my computer connects to Facebook, what actually happens on the way. Okay, when you type that on your browser, press enter, what happens. B, you should be able to see what is happening behind it. You should have an idea of what's happening behind the scenes. And C is there are certain things that we can learn, some general ideas, some general components of this system that we can extend to other things. For example, Facebook does something which is really, really different and interesting. Like Metaverse has come up recently. There's some AI algorithms that they have which are very unique to them. But there's a lot of generic things that they also do. For example, storing images. Okay, Facebook does it, Tinder does it, WhatsApp does it. Almost every company that is in the social media space or even in general saves images. So certain things are general. That is what we want to focus on today. Because as engineers, if you look at problems and you're able to solve them and generalize them, scale them, that is what we do as engineers. So at the end of this meeting, hopefully we'll have these three things taken care of, which will make us better engineers moving forward. Okay, if anyone has any doubts before we start the session, I'll just take a couple of minutes for this to sink in. If you want to drink water or get ready, go ahead. After that, we'll start with the session at 8:10. Any questions that you have beforehand, you can post it right now in the chat. I'll try to answer if you have any simple questions. But if you have, let's say, very specific questions, then I'll try to answer them later on after the meet. Thank you, Sania. Thank you, Gokul. Yes, Dash, this session is going to be for absolute beginners also. In fact, it is specifically targeted for absolute beginners. If you already know some parts of system design, or if you have gone through my YouTube playlist, or if you have gone through the Interview Ready course, this is going to be much more basic than that. The reason it is much more basic is because most of the times in colleges, system design is not something which is actively pursued because companies test you during placements for DSA. So you prepare also accordingly, which makes total sense. That's why I want to start at the basic. And if you like it, then you can, move forward to more depth in system design. Thank you, Vaibhavi. Okay, I think most of the people are excited, and this is great. Even if you know nothing about system design, as long as you pay attention, hopefully, you will understand everything because you're computer science students. Things should click. So one thing I'll do is I'll first start sharing my screen. Okay. Okay. My screen hopefully is visible. It's visible to me, so I'll assume that it's visible to all of you also. Okay, now firstly, let's take an example. We are currently in a Google Meet, right? So you have your own desktop. Some of you are also connecting through mobile. So we have different types of users. And now you need to start imagining as a person who's connecting to Google Meet. So there is www.meet.google.com. Actually, www is not there. It's meet.google.com. That's a subdomain. And then there's / something. Okay, DFW-EDTX-ROF. Okay, this is the URL we need to connect to. Now, your computer, when it starts off, what it does is, if you're connected to the Wi-Fi or even if you're connected by LAN, basically what happens is you pay your internet service provider, right? Airtel, Hathway, Reliance. These guys, they make a promise to you that I will make sure that you are connected to the internet. What they mean by that is, if you give me a particular address which is publicly known, right? Google.com is publicly known, then I can connect you there. What does that mean? You take your, when you type something on your browser, you actually send a request to your ISP. So your router somehow knows how to connect to your ISP. Okay, take it like that. And your ISP finds out what is google.com. It's an IP address. Okay, so maybe 192.3.2.1. So a particular IP address has to be connected to. You, as an end customer, have no idea how to connect to this IP address, but this ISP will give you a particular route. Maybe there's a router here. This is in India. Maybe there's a router here. This is in Europe. And another router here, which is in the US. And assume that of course, this might be a little more complicated than that. Maybe you want to optimize your route. So sometimes the route is changed midway. Sometimes you want to cache, where is Google, but you may not want to cache where is, let's say, VIT's internal server, because it's not very common. So you can store limited entries. So those are complexities, but this is the basic general idea. Okay. So now that we have this part clear, how you're connecting to an external system, let's focus on this part. Okay. Internals of Google Meet, let's say. Okay. Now, Google Meet is a successful company. It has a lot of money. It's a profitable company. Even if Google Meet is not profitable, at least Google is profitable. So during the pandemic, you can see a lot of people made requests from all over the world. Okay. So what can you see as a problem in this system? Let's say Google Meet. Firstly, there is registration, which is one problem that Google Meet solves, right? You can go to Google and you can register yourself. You put in your profile name, first name, last name. You can put password. You can do quite a few things. You can add your profile image also. And Google has to store this in a database and give you back responses. Do you see any problem with this system? Any problem at all during the pandemic? Millions of users. Sometimes, things can start thinking like engineers now. So engineers are half researchers, let's say. Okay, maybe 30%, 40%, 50%, depends on your role. But we are also mechanics. Or we are also, like doctors, we don't just care about, wow, this body is awesome, this process is working wonderfully, but the patient is dead. The surgery is successful, but the patient is dead, makes no sense for a doctor. Similarly, as engineers, if the system is beautifully designed, if the code is awesome and it's a very lovely algorithm, but it doesn't work, it doesn't work. So now start thinking like engineers, what are the things that could go wrong here?
The request could fail.
Okay, the request could fail. So it could be that the router, maybe while coming through maybe the request was not correctly relayed. That could maybe be one thing. Maybe the request was too slow. The router was very slow to send it to you. It could be that maybe you had a queue. So you were taking all these requests in a queue, right? In your data structure, think like a list. Whenever you're getting a request, you're putting it to your list, your linked list. And then suddenly the linked list is massive, millions of people. So maybe the linked list had an out of memory exception. So your entire application can collapse. If you say, no, I will only allow 1,000 requests Any more than that, I throw it in the dustbin. That is good. But then the request is actually literally failing. You're basically saying after 1000, I'm not taking any more. So I'll send you a failure response. That's also one thing that can be done. Anything else? Something more fundamental? What happens during an electricity outage in your homes? Like if you're watching this right now and there's an electricity outage, what will you do? Do you have an inverter, or will your computer shut down? Will your Wi-Fi is also on an inverter? What's it like? Yes, Darsh, I think you had a point there.
So basically, I will on the mobile network because my Wi-Fi is connected to the inverter also.
Okay, so you have your mobile network Wi-Fi, and if your Wi-Fi goes away, maybe for a few seconds you'll be like, oh no, I lost Gaurav there. I lost part of this meeting, but you have a mobile network. You have a backup. So okay, so first thing you want to do as a company, or even as a person who's remotely interested in providing a good service, is backup. Okay. Now, if let's say you have a backup, let's say your mobile network is good. Google Meet also has a similar thing. For a second or 2-3 seconds, it lost all connections. Okay, all Google Meets collapsed. Now, after a few seconds, everyone wants to come back. So instead of 1 million requests concurrently, now you have, in those 1 or 2 seconds, nobody answered the request. Okay, so people used to come, join, and then when they used to get a response, they used to do this. Like in 1 second, you used to get, let's say, 1 million. Now everybody has collapsed. So everyone wants to retry. And in 1 millisecond, you get 1 million requests. Is this making sense? Earlier things were going smoothly. You could take a request and give a response. Now what happened is, because the system collapsed and you came back on, everyone is like, hey, Google, make me join. So in a split second, you get millions of requests. So what do you think is going to happen to the capacity of this system? To a linked list, which has to be, like in computer programming also, order in, everything is fine. But at the end of the day, if I give you an array of size 1 billion, then you can't do much. So what's going to happen is, what I'm looking for here is that this thing can collapse. Right? It can also have electricity outage. Even if you have an inverter, what if there is some bug? It can be a code bug. It can be that the inverter also was faulty. The entire system collapsed. Plus, her computer. I mean, you don't put an inverter in every computer. Power outage is one thing. You can also have a hardware failure. So, as engineers, you need to start considering everything that can go wrong. You need to trust as little as you possibly can. So this thing can collapse. Now, can someone give me a solution for this? Like one solution by Darsh was that you can actually have a backup, which is an interesting idea. Okay, if you have a backup, what can you do? So Darsh, can you give me a little bit more explanation of what you mean by backup? Or do you have an explanation? Because you mentioned the Wi-Fi network moving on to mobile. So do you see something similar here?
Basically, we also need a backup for Google Meet if it collapses.
So this server, if it collapses, we need a backup for it. Okay. Now, switching to a backup, like I said, can be risky, but it is possible. So one of the things that we can do is, we can say, if you collapse, then please keep a backup server also connected. But who's going to turn on this backup? Who's going to tell all these IP addresses that please now start talking to this backup?
Load balancer.
Okay, you can have a load balancer. So a load balancer. So the concept of a backup here, Yash, will be that if you have a load balancer, means the load is being balanced roughly evenly. So that's a good idea, by the way. Let me just draw that out. Load balancer means every request is like kind of carrying some load. So you want to equally distribute that. You want to be in a situation where both the servers get 50% load, right? You can randomly distribute this. Maybe if you randomly generate a number, odd, go to server number 0, even, go to server number 1. That can be one idea. Okay. So load balancer is a very good idea. Yeah. If this server collapses, still the load balancer needs to know somehow that this person is now dead. So who's going to actually give that information to this load balancer that, hey, server 1 is dead. Whatever load was here, please transfer it here. How do you find out if your application is dead? That's the interesting question. Normally, like this happens in TV serials mainly, but in reality also, if someone is alive, how do you check whether the person is alive, or how do you check whether this person is responding? If you have a grandma and let's say she's alone, okay, so what do you do to make sure that she's okay?
Check for reflexes.
Check for reflexes. Okay, so you're over there and you're basically doing. It's a scary situation then, right? When you're actually checking for reflexes, pulling.
We actually check for the pulse.
I'm sorry, Anirudh?
We actually check for her pulse.
You check for a pulse. So these are, okay, you guys are absolutely right. This is the situation where the situation is critical. However, if, your grandma is normally fine, 99% of the time she's fine. So what do you do when you are at home, let's say in Calcutta, and she's in Vellore, and you have to, or you're basically in Vellore, all of you guys are, let's say you are in Vellore, and she's back home, and every day you want to check up on her. What do you do?
We can call to her.
You can call her, absolutely. So you are basically calling her and checking, is everything okay? How's your health? Are things fine? Just like that, you can have a health check service here. Just give me a minute, which is very messy. Okay. So if I have a health check service, which literally every 5 seconds, because this is programmatic, right? No one's going to get bored or irritated. Every 5 seconds, it makes a call. And we call this a heartbeat. So we check whether this service is actually responding with a 200 OK or not. A 200 OK in HTTP means that things are fine. Okay. If it doesn't respond with a 200 OK, if it gives, that critical state, or if it does not respond at all, which is much more likely, in that case, what you do is you try for one more time. Every 5 seconds you're trying. If things are going fine, 200 OK, things are fine. If it does not respond, then you try after 5 more seconds and put it in the critical stage. If it doesn't respond for 2 consecutive heartbeats, you assume that this service is in big trouble. Okay, and basically, because servers are easily replaceable, you assume that the system is dead. Okay. And then you basically, instead of having this backup running all the time, which is going to eat up our resources, in AWS, you have to pay for all this, or any cloud solution, you have to pay for all this. So you don't want to rent out unnecessarily. You that time say that, please, maybe the there's an engineering team, right, that you have usually, or you are doing it alone. You get an SMS that, your service is dead. Please start a new service. If you pay Amazon enough, then they'll do this for you automatically also. Okay, so they will spring up a new service, a new computer, which is going to run this same code of Google Meet in it. And basically you have no problem. Your users never got to know also that you had an issue. Okay, this is basically in case you have a failure. Now, there is still one problem though. All these people were connected to this box. Now, how do I tell them that please connect to this new box here? Like hundreds of millions of people are going to suddenly move to this new box. Is that practical? If you do that, right, what will happen is it will be very costly. Yeah, Darsh.
Yes, it's not practical, sir.
It's not practical. What can we do to try to mitigate this solution? Remember that in a company, usually if you see the developer operations people, okay, don't get me wrong here, but there is one team which is for stability of a service, for deployments, for making sure things are tested, for making sure that things don't break. Things break, people don't like it. Okay, if Google Meet breaks down right now, nobody's going to like it. 90 people are on this call, 90 people will be irritated. So you want to avoid breaking things. However, there's also another thing, which is features. So if Google Meet has a new feature, it wants to deploy it. The chance of the service breaking when you deploy is higher, but still you have to deploy it so that your business is running and you're healthy and things are fine. So two teams are kind of at loggerheads. Two teams don't agree with each other. Engineering team wants to deploy more features. Developer operations wants to not deploy any features. Okay, so this is a difficult question, but I'll give you a minute to think over it, just so that even if you come up with any ideas, I just want to see what you come up with. How do you avoid moving users, existing users, these guys, from one place, which is this box, to this new box? We know that services can die, okay? But still we want to avoid it as much as possible. What will you do to avoid breaking these connections and sending them to the new area? How can you avoid failing your service? And the hint is, the more code changes you have, the more chance you have of a service failing, and the more deployments you'll have. So what could be one idea that you could use?
Sir, I think if we use dynamic memory allocation, then actually the space used by some person can be again used by another person who is waiting behind it, like that.
Okay. So
in that case, a single space can be can serve multiple people, like that. Or okay, we can use
a smart idea. Yes. Excuse me. Yeah, but see, Dipendu, okay, you have 10 people using the same socket. Okay, you are really good at multiplexing. You're saying that here's a phone. Gaurav, you speak. You're done. Okay, Dipendu, you speak now quickly. So it's as good as one single connection, but 3 or 4 people are using it at the same time. However, if the phone connection is gone, then Gaurav and Dipendu both are unhappy. Right? One socket is gone at least. There has to be a change now. I have to pick up a separate phone. I, as an end customer, I don't need to do it, but Google has to do it. Google has to pick up a new phone because their older phone is collapsed, right? The socket has died. Basically, the hardware has to be changed. So how do you avoid switching those connections? Those are expensive. You have to create a connection. Like in TCP, you first say hello, the other guy says hello, then you send some data. So that requires a little bit of connection creation, and looking at 1 million users coming together and saying connection creation, that's going to be pretty expensive. Okay.
Sir?
Yeah.
So the requests are coming on a particular IP address, so we can assign the new server with that IP address. So the request will remain on the same IP address, and we don't have to switch the.
You're very, 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 very close. Yeah, but the problem is, okay. Can you? Okay, let me actually draw that out. You're close. Okay. Basically, we don't care who you connect to internally. Externally, the IP address has to be same. Otherwise, people will be upset. It's like changing a phone number every day. Can't do it. People will go mad. So you don't want to change your IP address also. Okay. Okay. So IP address has to be constant, or not constant, but it can't go on changing. So for that, there needs to be a box which is serving people just their connections. And here, if you go, there has to be the Google Meet server. So Google Meet server 1, and you have Google Meet server 2. And like Darsh was saying, let's have some backups. Google Meet server 3. Now this box, this is a box, okay? This is actually This is actually something which does connections. This can direct requests over here. GM1, GM2, GM3, different boxes. Now you're doing load balancing. This is basically, it's handling connections and doing load balancing. It will get responses also. So that's okay. When it gets the response, it's going to forward it back to the customer. Is this part making sense? You have now separated out Google Meet services with connections. Why did we do this? What's so great about it? Gaurav, yahan pe agar, if electricity outage is there, then what? You're going to get God to come here and fix it? No. I can't fix electricity outage. But what I can do is, every time a person deploys some code, every time a person gets excited and says ki mere ko ek naya video add karna hai yahan pe, maybe I want to add a new feature. I don't know, tomorrow Google might say that I want to allow participants to talk to each other without the speaker being able to see it. Okay, a new feature, something different. The code has a chance of breaking. If the code has a chance of breaking, then my users have a chance of getting lost here, the connections being lost here. I don't want to do that. So instead, now if the code breaks here, nothing happens here. This is still working fine. Right? These requests will fail. That's okay. No problem. Put in a new server, GM3, and connect this box to this. Is this making sense?
So is this a proxy server?
Yes. It's called a reverse proxy. Reason it's called a reverse proxy is because if people connect to you, they have no idea who they're actually connecting to. If you know about NAT, network address, basically if you're connecting to me and I say that, like Amazon, basically, if you connect to them and you tell them that give me an order here in my house, of course they give you details also of the thing, but you don't know who is actually doing the last mile delivery. So who's actually doing the work, nobody knows. Only this server knows. And the client doesn't want to know also. You don't want to know right now, using Google Meet, that this room, which server of Google is serving it. There are multiple servers, one of them is serving it, we don't care. If the server which is serving this Meet goes down, I don't care. You spin up a new server, another GM3, and then you route it there. We will never have an idea about what happened behind the scenes, but things are running fine for us. Is this making sense, guys? The intent of this is to make sure that this connection service never goes down. If there's an electricity outage, we cannot save it as engineers, but we can definitely save code bugs and features being deployed from breaking all these connections that we have here. Every time you have a new code release, like not for JavaScript, but every time you have a new code release, your server needs to restart. Your code has changed, a new deployment happens. New deployment means all the connections you had earlier in your list, this is in memory, right? They will break, you lose them all. If you keep it in a database, you have to load it all from the database. You don't want to do that. You want to keep it in memory only. You never want to restart server. So if you don't want to restart server, you don't have to change code ever. Don't want to change code ever, make the code as simple as possible. Complex code you give to other services. Is that making sense? बहुत ज़्यादा fast बोल रहा हूँ. Am I speaking too fast?
So it's completely fine.
Okay. It's making sense. If you guys have doubts, let me take 2 minutes के doubts till 8:40. Let me know your doubts. If you didn't understand anything only, that also you can post. You can let me know. I'll try to clear this.
Sir, what are that IP address? Actually, there are. You said there is a single Google Meet. So from where these many Google Meets are coming? GM1, GM2, GM3. So how it is coming like that, sir? Actually, I'm not getting that.
That's a good question. Okay. Anyone else also having that question? GM1, GM2, where are they coming from? So, okay. Now, what happened here is GM1 is profile storage. Let's say, okay, this is one piece of code, one program that you ran. So you wrote it in Python profile storage.py. It started to run. Okay, this is one box. It's running in Chennai. However, if there's a problem in Chennai, okay, maybe there's a network outage or something, you have another critical storage, which is payments. So Google Pay, or let's stick to Meet here. So I'll call it chat. So the chat code, the code related to chat, all sorts of code which is related to chat is running on this box. Okay. You're seeing these are different programs for the same product for Google Meet. Google Meet needs chat. Google Meet needs profile storage. Google Meet needs sessions. Okay. 3 different things running in different computers, possibly, maybe in different countries also. Because that is just code, right? Code can run anywhere. So there are different computers which are being connected to by a single connections box. Okay, connections is also code. There is code running inside it which is enabling it to make connections with people in different parts of the world. When a person says, please update my profile picture, connection says, okay, fine. What happened when you did meet.google.com/room ID is that basically this connection server went and said, where is the room service? So there is a box running, let's say in China, which is running code for rooms. It has its own database also. Every time a person connects to it, it goes and stores that information in the database, does some manipulation which is required to make rooms. Okay, room is a logical entity for Google, and it gives back a response. Is this part making sense? Different types of code are running in different parts of the world, doing different things. You connect to it by actually mentioning what you want to do. Yahan pe if you say question mark profile ID equal to XYZ, then it will go and fetch profile ID. Because different parts of code are specialized for doing different kinds of things. You might not even go through connections. Chatbox can talk to these guys. This is internal. This is the Google Cloud. All these boxes are connected to each other. They can be. For security reasons, sometimes maybe you don't want payments to connect to everybody, but they can be.
Sir, so in our previous case, the main question is that failure of the main server to which users are connecting, right?
Right.
So in this case also, there are chances of failing of the connection box, right? So
Absolutely.
what we have made as improvement?
So one improvement is, if the connections box fails, Google Meet is gone. I agree with that 100%. What we have done is we have taken out logic of the product and put it here. What is the benefit? Now, if I need to make some product changes in Room, if Room used to take only 100 people, now it is ready to take 300 people. Because of that, I had to do a lot of code change in this box. If I did some code change for it to reflect, for a program to have new code, you restart, you run the main method again. No? While running the main method, you can't change the code and have the code running with the new capabilities. So you need a restart. When you do a restart, the state of this box, everything in memory is cleared, right?
Yes,
so,
sir.
Right. So if the state of the box is cleared and you restart, okay, this is happening. If the room code was in connections inside this, then when you would restart, you would lose all the connections. Now you're not losing those connections. Now only this box is restarted.
Just we have reduced the. Just we have increased the efficiency of this thing, right?
You have reduced the.
No, we have increased the efficiency, right, sir?
Yes.
Now we lost connections.
We have increased the efficiency.
In the previous case, the connection loss is heavy. Right now, we just reduced it, right?
Yes. We have reduced the chance of
Connecting the servers. Okay, sir.
That's one thing. There's also a few other advantages. Let's say that chat is very expensive. So now I want to, one chat box is not enough. People in India and USA and all countries combined, I can't find a supercomputer also which can handle these many people. So I take another computer and run the same code that the chat box is running. This time I'm running it in India. This was in China. Now I'm running it in India. Now, if there is a chat request, okay, somebody makes a chat request, I can send it here or I can send it here. The connections box, the load balancer figures out where to send it. 50-50. Randomly it assigns it. So what have I done? I'm able to individually scale this. I'm able to tell key, see, I'm not wasting resources. Why? Because earlier, if you had all the code in this box, profile, chat, everything, then, and I was running out of space, then I would have to buy a big box, which did everything again, profile, chat, everything. Instead, now I take a much smaller box, which is just for chat, and I'm still happy. This cost me $10. Buying a new box for all the code combined together would have cost me $50. But that would be wastage, of 40. Maybe profile also, I'm running out of space someday. I'll say, okay, take $10 more and give me a profile server. Is this making sense? As a business, you are able to take parts of the business which are under pressure and focus on just scaling them instead of scaling the entire code. That is also one benefit of just separating out this thing. This is called microservices.
Sir, like we have just splitted the different thing to the different server for some benefits, but still we have the same risk, right, sir? Failure of if there is as we assumed the power outage.
Yeah. Okay.
Like,
no, let's
we didn't
but
made
you
any.
appreciate that certain things are now A, less risky, and B, as a business, cheaper. This is cheaper to get more boxes, smaller boxes for specific requirements is cheaper. That is one thing. So what have we done? Of course, we cannot solve everything in the world. If an asteroid hits us, we are gone. Even Google is gone. But one of the benefits of this is, let's take it step by step. Let's take, it is cheaper, A, and B is chance of connection loss is lesser. Important thing here is chance. There is no guarantee. There is everything. You will see soon as engineers, when you start working for companies, everything is chance. Things go very bad, of course, you will be much more concerned for many other things than this system. So you're just reducing chance for now. Okay. Is this part making sense to everyone?
Yes, sir.
Yes.
Cheaper, chance is better. Okay. Now let's go for the final thing, which is, Yashwant has a very good point, which is what happens if connections are lost. So A, you can't avoid it, but you can mitigate the problem a little bit. Let's say you have one connections box here, connections box 1. Similarly, and this is in the US, let's say, I take all the Indians and I say this is connections box 2, just for Indians. And so for every country or every region, basically maybe Europe, you can take many countries, put them together. China might need its own box. So like that, you basically take connections and you take multiple boxes. So connection box 3. Okay, they are all running the same code, exact same code, but different people are connecting to it. So Indians connect here, the Americans connect here. In terms of Google Meet, this will not make much sense. Okay, I can get an American guy and add him here. So actually, there'll be a different way to regionally also we can shard. But for example, let's take it this way, and some other people are connecting here. The rest of the world is connecting. Okay, now there's a lot of connections here. What happens if one of these boxes goes down? People from UK were connecting here. Where do the UK people go? Should we ask them to wait? That is reasonable. Okay, nothing is a bad solution, by the way. Everything is dependent on product. Everything is dependent on how much money you have and how much you care about those users. So if the UK users say, I'm not able to use Meet, and you as a business say, that's okay, you wait till this box comes back online, Okay, that's a business decision. So that is one option. Ignore. Okay, or wait for correction. Power will come back, electricity will come back, things will go fine. That is one way to think. What else can you do?
You can redirect the connections.
Yes, absolutely. You take the UK connections and you want to redirect them. So how do you redirect them? Let's say you take 2 of these connections and send them to the Indian box, and this connection you send to the US box, because you want to roughly balance it out. So we talked about this in the start. Sorry, here. Remember here. How
So
will you
how the
redirect
proxy works, right?
Sorry?
Oh, we use the router.
Yeah, not the proxy. Proxy is when you have talked to Google, you have touched Google at that point. But Google India and Google, and you're kind of right also. Maybe you have a big server here which is connecting to all three, but that will be a bit wasting. Okay, why will Google do that? Google will say, if you are connected to a DNS, sorry for this. If you're connecting to a DNS, I have 3 IP addresses. India, I also have USA, I also have UK. So the Indians, when they come here, they say, first closest person to me is India. Let me try to connect there. If the Indians cannot connect to India, then they try the next one in the DNS. So the DNS does this automatically. They first try to route you here, then they try to route you to the next in the list. So what do you have to do here? You have to pay more money to DNS. You have to say, I'm taking more mappings. So that's basically the idea. And US bhi nahi chala, if US is also down, then we'll try to connect you to the UK. Are you seeing the DNS is actually working as a load balancer now, sort of? Right, but your business is running. All 3 have to go down for your customers to be unhappy. Is this making sense? Okay. I'll assume this is making sense. There is one small problem though. Let's say India and US are both, or let's say UK and US are both down. Okay, so USA and UK are down. Everybody is connecting to India. Every single person. So 1, 2, 3, and this green user also comes here. These 3 users also come here. So there's tremendous load. Apart from load, I mean, you can't avoid this, right? If things are crashing, then like at least you have India, which is still running. What problem do you see apart from the load? Do you see any problem if everybody's connecting here? If the UK people are connecting to India, especially, and the US people are connecting to India?
The chances of India going offline?
Yeah, you're putting a lot of load. There's a chance that India will go offline. It's a cascading effect, no? Like, it's like 4 people were taking 25 kilos, then 1 person died, so you have to take their load. Then 2 people are dead. Then last person, 100 kilos, no way this person can walk also. Okay, so it is going to die. But forget the load. Let's say India is you have a supercomputer here. It's something that Netflix does. You can have a look at my YouTube video on this to get an idea. We talked about ISP. When you want an ISP, do you go to Reliance or Airtel, or do you go to T-Mobile in USA? Go to Indians, right? Because what example can I give? I don't know if this makes sense. Let's say you have Domino's Pizza, okay, nearby. In 5 minutes, they can deliver 5. The pizza service goes down. Yeah, they had some legal issues. So you have another Domino's which is quite far, 10 kilometers away. What's the problem? Very, very basic thing. It's basically what has happened here. US people are coming to India. What is the problem?
The pizza can't be delivered in 5 minutes.
Taking time.
Pizza can't be delivered in 5 minutes, taking time because physically you are too far away. USA is on the other side of the globe. By the time they send us a request, it takes 1 second. You send them a response, takes 1 second. Page response time, 2 seconds. Let me show you that. That's how long the pause is. You're getting irritated. You want to send a chat to somebody, it takes you 2 seconds. It's a lot of time. So the problem with redirecting users like that is it's slow. Okay, so it's slow because physically you are far away. So if you can have multiple connections, multiple pieces of code running in USA itself, let's say 3 or 4 boxes, then if this fails, at least you can redirect them here, right? So the DNS won't have one single IP address. Maybe it will have 3 IP addresses for India and 3 IP addresses for USA and so on. Are you seeing a general engineering idea always, which is throw more money at the problem and things are solved, right? Replication, redundancy, all of these terms basically mean get more things of the same type so that our problems are solved. This is 90% of the times what happens. If a surgeon, their scalpel breaks, they don't say, oh my God, what do I do? Send him to the other doctor. They have another backup scalpel, right? So that's one of the things we are doing. The other thing that we are doing is we are doing load balancing. If suppose the surgery room lost all electricity, you send them to the other surgery room. You don't just give up. You kind of balance load there. You have a backup. You can call it a backup, but you can also, let's say you go to the other surgery room and you adjust over there. Load balancing. Okay. So in general, what I'm trying to say is there are certain patterns that as engineers you will do multiple times. You will balance load, you will split load and send it to nearby places, cheapest, fastest, best. That's what you want to do as an engineer. As an engineer, you also want to make sure that things never fail. If you have written a piece of code, it does not crash. Okay, you do that through replication, through redundancy, usually in hardware, and in software you do it through tests, or you do it through like multiple people trying to break into it. Basically, as an engineer, you're thinking about how can things fail and wrapping sellotape around it to make sure it doesn't fail. Okay. So is this overall system making sense, guys? How you connect to a particular place, what happens inside it, and then what are some basic engineering principles we can see from this? If it's not, it's okay. You can send your doubts on the chat, or right now you can talk also.
Sir.
Yeah.
Sir, when we send a request, what does the DNS server do? Can you please repeat it? Like if you are sending www.facebook.com, so what does a DNS server do?
So a DNS server is going to help you. So technically what will happen here is that let's say you, through your mobile in your browser or maybe through an app, you send that HTTP request. You want to send a request. So it needs to be mapped to an IP address. Right? Every computer has an IP address. We need to send it to a particular IP address. So who knows that? Facebook is today running in Los Angeles. Tomorrow it is running in Detroit. Wherever they find cheaper land, they'll put their computers there, bhade pe le lenge land, and they'll set up their computer. So you have no idea which IP address is actually being connected to. And you don't want to know also. You only remember facebook.com. That facebook.com needs a mapping to an IP address. Right? That is what the DNS does. The DNS says connect to this IP address. It gives you the IP address. Now, actually what happens is you get that IP address, and then through routers, you try to connect to it. You try to connect to Facebook. So there's multiple routers on the way, which are like, hey, do you know where this IP address is? So one of them says, yeah, I know, but actually it doesn't. It just knows a person who knows where the IP address is. So like this, it's like, do you know Shah Rukh Khan? No, I know a person who knows Shah Rukh. And actually that person also doesn't know the person. They are going in this long chain. But IP address will help you as a router direct you to the right person. Yeah, so this is Google, let's say. And the original, this IP address is actually this machine's IP address. Okay, you can have a look at Border Gateway Protocol to read more into this. But yeah, is this idea clear, Sasi Pawan?
Yeah, it's clear.
Okay. So that's what the DNS does. DNS just gives you a mapping. Routers send them in the right place. Okay. What is this thing? Excuse me, sorry. When you type something on the browser, which protocol are you using? Anyone, can you answer? लिखा भी आता है उधर ऊपर.
HTTP.
HTTP, okay. HTTP is the protocol we are using. You're absolutely right. If you go to level 4 of the OSI model, or like, what is HTTP written on top of? So HTTP is
TCP.
TCP, absolutely. Yeah. So these routers are usually working on TCP. Okay. That's how they're sending it forward. The IP address, figuring out where the IP address lands. So yeah, basically HTTP, TCP, these are things, basics that we would like to know as engineers. TCP, the reason we use it, you can have a look. But yeah, basically you want reliable delivery, ordered, all of that. Okay. Anything else? Any other doubts? Okay. If you do have any doubts, you can always contact me. I think you can try this GKCH at scalability.tech. This is the email address that you want to contact. If you have not seen my YouTube channel, which is on system design, all the content there is free. If you're interested in system design, then definitely go there and check it out. It's basically this stuff and starts with basics and goes to advanced. So I would strongly recommend you, if you're in your final year especially, to understand how these systems work. Because, let me put it this way, all of us got jobs through computer programming in direct tag, right, everyone. But the moment we joined, for some reason, they were expecting us to know software engineering. So this is what will be happening actually inside the job, and things that you actually need to know. To be an actual software engineer, this is what you need to know. And yeah, if you're interested in these particular things before you joining your job or your internship or something, that's something I would strongly recommend. You should know about it. You can go to, my channel name is Gaurav Sen. There's a system design playlist. That's the thing that I'm talking about. Cool. Okay, guys, if you have any doubts, then you can always mail me here. Or
sir, I'm having a doubt, sir. Like, it's kind of personal.
Yeah, of course.
Nothing related to things. Sir, how build a Unity game on my own? I want to take it to online. How should I do? Online in the sense not to the app market. Just I want to connect to players, online players. What's the steps? What are the steps?
You have a game which you want to make public, or?
Yes, sir. Connect the users online. It's like a multiplayer.
Okay. No. I'm understanding what you're saying. You need a website most likely if you want to make it a product. And then multiple people will connect to it, and then you'll let them play. If you're talking about the technology, no, I don't want to get into the tech. If you're talking about how to run this as a basic technology business, you need a website. Okay, you need to get people on board. Are people really interested? If you don't want to do that, if this is your side project, you're doing it for fun, then try to connect people. Just open your LAN address, let friends nearby play. Oh, during COVID you can't do that, so yeah, that's a problem. You guys are missing out on the LAN thing. What to do? You can host it on a site, and it will be reasonably cheap. Go for a stupid website like XYZ PQRS, something like that. 99 rupees. That's the only thing that I think which is making sense. Yeah. Sorry, I can't help more than that. Only paid solutions for our websites. For LAN, though, of course, it's free. It's fun. Okay. Anything else, guys?
Thank you, sir, for such an informative session. Guys, if you have any questions, you can post it in the chat box.
Let me also do a lot of self-promotion here. You can follow me on any of the social media handles, and you can contact me directly also. So if you have some doubts related to system design, then I would suggest you don't even mail. Actually, I'll not read it mostly. Post it on YouTube, the comments. There's a lot of people who are already posting. People see also, they help each other out. It's a community. Are you guys in Discord? Discord.
Yes, sir.
Guys are in Discord, na? So, would you guys like to join my Discord server where people talk about system design and interviews and in general, those things only? Yeah, I'm really good at sales, right? An engineer who's really good at sales. Yes. Right. So generally, okay. Sasi Pawan is asking, can you discuss about the Facebook outage that happened a while ago? Is it related to the system design? Yes, it is. I told you guys to read about border gateway protocol, na? कहाँ पे? यहाँ पे ना? हाँ. If you read about this, okay, I'll give you the high level gist. Basically, the connections box we had, no? Facebook is a company which says that if my server goes down, if the health check service says that the connection box is dead, then kick it out of the DNS. Right? DNS should not send requests over there unnecessarily. So the health check service normally does correctly. It sees whether the box is alive. This is the health check service. We made some health check service here, no? So if it says that your box is alive, that means you're alive. But code deployment, ke time pe the box is dead. And also in certain cases, you want to tell that the box is dead. So somebody internally, by mistake, okay, without any bad intention, they removed themselves from the DNS. So routers were not able to touch Facebook. Imagine Facebook is here. Nobody is able to talk to Facebook. They themselves went and told all the DNSs to remove us. So basically in the protocol, you can deregister. So the idea is if you're deregistering, you register. No, you come back. They didn't come back. They just deregistered. And they stayed like that for hours. So nobody's able to connect to Facebook. Even their internal employees were not able to connect to Facebook. So like I run Interview Ready. Interview Ready is a company which is running on Amazon, AWS. Okay. So if I tell Amazon that I am gone, then nobody can connect to me. Just like that, Facebook went offline. And for a few hours, they were not able to figure out what's going on because none of their internal services were working. So that's what happened. Okay, any other doubts, guys? I don't think so, no? I'll just wait for one more minute, 9, 10. then we can move. But I would like to thank you all for your Friday evening. I know you have Shark Tank, you have many other things that you can watch, but you're here, you're learning about system design. It's commendable, and thank you for listening to me for this time. It's amazing. Okay, guys, I don't think we have any doubts. Awesome. Thank you, Vasu. Thanks, Aryan. Thank you, Athar.
First and foremost, I, Aditi Verma, would like to extend my heartiest gratitude to our distinguished speaker, Mr. Gaurav Sen, to the time and effort he has put into delivering such an enlightening session for us. And I'm sure that all the participants here would have gained immensely on this field of system design by attending this event. Lastly, I would like to thank each and every person who's attended this event and made it a success. We have left Innovators Quest socials in the chat box to follow us for more such exciting sessions. Thank you.
Thank you, everyone. Bye-bye. Take care. Have a great weekend. See you.